You know, I have no single.
Aras.
Hey! Were you not listening to your chemistry teacher and now you're in this video to learn about covalent bonds?
So, let's take a tour. What is a covalent bonding? Originated from the idea of Gilbert Lewis, that is, covalent bond is known as the interparticle bond formed by the sharing of an electron pair between two atoms. No atoms are stolen, but only shared. Covalent bonds between atoms are formed to increase stability, which is attained by constructing a complete electron shell or by drawing a Lewis dot structure. A Lewis dot structure is a very simplified representation of the valence shell electrons in a molecule. It is used to show how the electrons are arranged around individual atoms in a molecule, where electrons are shown as dots or for bonding electrons as line between the two atoms. To better understand, let us take a look at this. A lone pair refers to a pair of valence electrons that are not shared with another atom in a covalent bond and is sometimes called an unshared pair or non-bonding pair. Lone pairs are found in the outermost electron shell of atoms. Meanwhile, a bond pair is a pair of electrons that are in a bond. A single bond is always composed of two electrons that are paired with each other. These two electrons together are called the bond pair. Bond pairs can be seen in covalent compounds and coordination compounds. Well, there are three types of bond pair or bond order. A single covalent bond is a type of bond order where only one pair of electrons were shared between atoms. This is represented by a single line. This usually occurs in elements with 7 valence electrons such as chlorine, fluorine, and bromine. Double covalent bonding is another type of bond order where two pairs of electrons were shared between atoms and is represented by a double line. Compared to the single bonded molecule, molecules from double bonding are more stable and stronger. An example of this is oxygen gas. Oxygen has 6 valence electrons, therefore it needs another 2 to complete the octet. The triple covalent bond is the last type of the so-called bond order. This bond order requires 3 pairs of electrons to be shared between atoms. Triple covalent bonding is also stronger and the most stable among the bond order. An example of this is nitrogen gas. Since the valence electrons of nitrogen is 5, therefore it still needs 3 electrons to complete the octet. And in order to do that, the atom needs to share with another atom for the 3 electrons. The bond orders are not only limited to share with their own elements. We have nonpolar and polar bonding. What is it? A nonpolar covalent bond is a sort of chemical bond that occurs when two atoms shared electrons evenly. As a result, the number of electrons shared by neighboring atoms in an atom will be the same. Because the difference in electronegativity is usually small, the covalent bond is also known as a nonpolar bond. Meanwhile, a polar covalent bond is a bond formed when a shared pair of electrons are not shared equally. This is due to one of the elements having a higher electronegativity than the other. Maybe you are wondering, what is an electronegativity? Electronegativity is a chemical property that describes the tendency of an atom or a functional group to attract electrons toward itself. The electronegativity of an atom is affected by both its atomic number and the distance that its valence electrons reside from the charged nuclei. Now, going back to Lewis's structure, it will not always be perfect. We have this so-called resonance.
No matter what they say, no matter what they do,
Stop it, Samantha! So, resonance structures are drawn in a situation where one Lewis structure cannot accurately represent a bond. Resonance is a term used to describe the localized electrons within molecules or polyatomic ions whose bonding cannot be represented using a single Lewis structure.
Wait, what is an octet?
Ooh, the octet rule states that atoms tend to form compounds in ways that give them 8 valence electrons, and thus the electron configuration of a noble gas. Well, there is an exception to an octet of electrons, which is in the case of the first noble gas, helium, which only has 2 valence electrons. So, I think that will help you for your surface knowledge about covalent bond. Thank you for watching, and if you're new here, please subscribe to my channel and hit the like button.
Drawing the Lewis structure is as easy as 1, 2, 3, 4, 5. Well, maybe not, but close enough because there are only 5 steps in doing so. First is to draw all atoms with the correct number of valence electrons. To know the number of valence electrons, you can refer to your periodic table. The number of valence electrons is equal to the atom's main group number. For example, lithium is in group 1, meaning it has 1 valence electron, and so forth. Meanwhile, the transition metals have different valence electrons, so which are more complicated to find, so you can just search it up on the internet for tutorials. For example, we'll do the Lewis structure of difluoromethane, which is CH2F2. Chlorine has 4 valence electrons, while hydrogen has 1 and fluorine has 7. This is the Lewis dot structure of each of the atoms in this compound. Moving on, step 2 is to determine the center atom. Most Lewis structures, especially when we're just starting off, will have only one center, which is bonded to the rest of the atoms. Remember that it should have the least electronegative atom. Going back to the example I just said, the center atom cannot be hydrogen because it can never be hydrogen as it can only make one bond. Hence, it cannot be the middle of anything. Between the fluorine and carbon, fluorine is the most electronegative element, and carbon is less than that, so the center of our Lewis structure is carbon. Step 3 is to draw the center atom surrounded by everything else. The third step for our problem looks like this. Next, draw a single bond between the center atom and everything else. A bond of a covalent bond always represents the same exact thing. It represents 2 electrons, and so even when we are drawing it as a bond, what it really actually is just 2 electrons. So which means 1 bond is equal to electrons. So you can draw single bonds between the center atoms and everything else, but you need to make sure that whenever you do this, you're connecting 2 dots, one on one atom and one on the other. 1 electron can only participate in 1 bond, so we can double up and connect multiple bonds to the same electron on any atom. Here is our problem, which is difluoromethane looks like when we apply step 4. The redrawn version is like this. Next is step 5, which is you need to check if each atom has a full valence electrons. 1 bond is equal to 2 electrons. In our example, we can see that the hydrogen has 0 electrons, but has 1 bond which is equal to 2 electrons, meaning that both hydrogen in our example have full valence. On the other hand, carbon has 0 electrons left and has 4 bonds that are equal to 8 electrons. This atom also has full valence. Lastly, the fluorine with 6 electrons left and 1 bond which is equal to 2 electrons. 6 plus 2 is 8. Henceforth, the 2 fluorines in the Lewis structure of difluoromethane have full valence because they have the same left electrons and number of bonds. So yeah, that is how you draw a Lewis structure.
Let me introduce you to covalent bonding. First of all, to be able to determine and draw the covalent bond between elements, we must first know the difference between ionic and covalent bonds. Ionic bonding is a transfer of electrons from one element to another and commonly contains ions. Take for example, the bond between sodium and chlorine. Sodium has 1 valence electron while chlorine contains 7 valence electrons. The reaction between these 2 elements causes sodium to lose an electron and gain a positive charge, whereas chlorine gains the electron and acquires a negative charge. On the other hand, in the covalent bond, electrons are not transferred but shared. As an example, let's take the element hydrogen. A hydrogen atom has 1 valence electron. Note that elements under the same group contain the same number of electrons like hydrogen and sodium in group 1A. Furthermore, Elements in the first row, hydrogen and helium, usually want to gain 2 valence electrons, while the second row elements won't have 8 valence electrons. Hence, elements like oxygen and fluorine would want to satisfy their octet. So back to the example element H. If 2 hydrogen atoms combine, they're going to share electrons and form a bond. This figure is called the Lewis dot structure. 2 dots are also represented as a single line. Anytime elements or compounds share electrons, it is considered a covalent bond. Moving forward, there are 2 types of covalent bonds, polar and non-polar covalent bond. Back to the first example, hydrogen. The bond between 2 atoms of this kind is called a non-polar covalent bond. Herein, electrons are shared even. In non-polar covalent bonds, electrons between atoms are shared more or less even. On the other hand, let's have another example. The bond between hydrogen and fluorine. Because fluorine is found to be more electronegative than hydrogen, fluorine tends to pull electrons toward itself. Thus, the bond between these atoms is shared unevenly, making it a polar covalent bond. You can search for a chart of elements' electronegativity or refer to a chart that your teacher advises. Also, the sharing of these atoms causes hydrogen to gain a partially positive charge while fluorine gains a partial negative charge. In this reaction, you have a dipole. You have unequal distribution of charge, hence the bond is polarized. For more examples, let's classify the following bonds as being ionic, polar covalent, or non-polar covalent. First, magnesium oxide. To determine what the bond between these atoms is, it's best to check first if it's ionic. Typically, an ionic compound contains a metal and a non. That is how you can easily identify whether a bond is ionic or not. You can refer to a periodic table for this. Since magnesium is a metal and oxygen is a non-metal, the bond between magnesium oxide is considered ionic. Next is 2 chlorine atoms. By definition, when the given bond contains 2 nonmetals and is the same element, it is considered a non-polar covalent bond. The electrons in this given is shared equally as the elements are both chlorine. Third example is hydrogen bromide. As both elements are nonmetals, but different, this may be a polar covalent bond. However, we aren't sure. So for another way of determining the bond, we can find the difference in the electronegativity of both elements. When atoms of different elements share electrons through covalent bonding, and the electronegativity difference between the atoms is not high enough to cause ionization, but is at least more than 0.5, the bond is called a polar covalent bonding. Meanwhile, if the electronegativity difference between the atoms is less than 0.5 or equal to 0.4 and below, the bond is said to be nonpolar. Now, hydrogen has an electronegativity of 2.1 and bromine has an electronegativity of 2.8. Since 2.8 minus 2.1 is equal to 0.7, the electronegativity is greater than 0.5, and so it's considered a polar covalent bond. And that is all.
To help you guys better understand covalent bonding, I'll be going over its definition, how to identify a covalent bond, and how to start drawing out covalent bonds. Covalent bonding is a type of bonding that happens between 2 or more nonmetals. We use the periodic table to help us identify whether something is a metal or a nonmetal. In covalent bonding, electrons are shared, not transferred, so it's all about sharing. So now, let's look at a few examples of molecules and see if they're covalent or not. First, we have CO2, which means that we have 2 chlorines. Chlorine is a nonmetal, so we have one nonmetal, chlorine, and then another nonmetal, or second chlorine. As a result, this molecule is covalent. The next element is NaBr, or sodium, a metal, and bromine, a nonmetal. So one of our atoms is a metal, and the other is not, indicating that this is not covalent. A metal and a nonmetal, that's going to be an ionic bond. Lastly, we have H2O. So H is a nonmetal, and we also have oxygen, also a nonmetal, making this a covalent bond. Alright, so let's do an example. H2O. Starting with just drawing out their valence. We have 2 hydrogens, our subscript of 2, so H has 1, another H has 1, and O has 6 valence. So we now have 1 valence, and 6 valence. As a result, everyone wants a full valence shell. This means that H wants to get up to 2, and oxygen wants to get to 8. So first and foremost, we will not connect the 2 H's. If we did this, there would be no place for oxygen to join because the 2 H's would each have their own electrons. We're going to connect each H to the oxygen atom, and this oxygen will say, okay, some of the time I'm going to give you my electron, and the other half of the time you're going to give me your electron, plus the one you borrowed from me. So for this H, it would be like this. It doesn't matter what electron it is as long as it's on the oxygen. And then the other hydrogen says the same thing. I'm going to take one of your electrons for half the time and give you mine for half the time in exchange. And then oxygen replies, great. So what I'm going to do is take back not only my electron, but also take your electron, and that's how I'm going to get my 8. Let's draw this another way. So as we can see, oxygen has 4 electrons on top that did not bond, and it now has a bond to H and another bond to H. That's basically it.